you understand what you're doing with that page of problems. Now, we've looked in the past at equations and balancing out those equations. And you remember it's the x is on one side, numbers on the other. X is on one side, numbers on the other. And you can do whatever you like to either side as long as you do it to both sides. So if I want to add something to both sides, totally cool. If I want to subtract something from both sides, totally cool. Multiply, divide, same deal. So on this one, what I'm going to do, because I want x's on one side, numbers on the other, I'm going to take away 1 from each side, and that's going to give me nothing. That's going to wipe out 1 and negative 1. That wipes out. 3x equals 12. And at that point, I can look at it, and I'm probably mentally going to think to myself, well, 3 times 4 is 12, so my answer is 12. Or I might think to myself, I could divide both sides by 3, and that would get me down to my final answer. X is equal to 4. Now, we've been doing the same thing with the inequalities. X is on one side, numbers on the other. No difference whatsoever. Again, same problem, but notice I'm using an inequality sign. So I'm going to wind up with 3x is equal to 12. Oh, I'm sorry. I'm on the last problem still. I'm going to wind up with 3x is greater than 12. And again, I can divide that. And what my answer is going to wind up being is x is greater than 4. All right? X is on one side, numbers on the other. And we'd graph that as, put the dot on the 4, and it's a hollow dot because 4 is not an answer. We've talked about that. And it's going this way. X is anything bigger than 4. Now, today, you're going to be looking at, you've got 2 signs. You have a compound inequality. And instead of x's on one side and numbers on the other, our new mantra is x is in the middle, numbers on both sides. So again, you can do whatever you want to this equation as long as you do it to all the parts. So, for example, I really want this x to be by itself. And a handy way to do that would be to add 6 to this side, because negative 6 and positive 6 zeroes out. However, to keep it right, I have to do it to each side. So this is going to wind up being 12. This is going to wind up being 15. Okay? And that is going to be that. X is greater than or equal to 12. X is less than or equal to 15. Now, let's think about how we're going to graph that, which is the second part you have to do for those problems. You have to make a graph for every one. And so we'll drag one of these out here. Oh, you know something? That's not going to be big enough. So we'll just do this. That's kind of fun. We'll do this without the number line because it only goes to 10 on both. So I've made a mess here. Let's see if we can get this cleaned up. We're going to go insert. Let's insert a blank page. See if I can remember what I did here. We had, I believe, x there. And yes, less than or equal to 15. So my graph will look something like, here's my 15, and 15 gets solid because it's part of the answer, and 12, and again, it's a solid dot because it's part of the answer. So x is greater than 12, but less than 15. So it's a line between those. All right? And so that's the run through on the first problem.